Ever get that feeling? Like you keep hearing about something big, something you know you should probably understand, but actually figuring it out, well, it just feels overwhelming.
Oh, yeah. I know exactly what you mean. It's like, it's important, but where do you even begin?
Exactly. And that's what we're diving into today with Kubernetes.
Makes sense. Kubernetes, it's definitely a buzzword these days, and for good reason. It's really shaking things up in how we're building and running applications today, modern applications.
Yeah. Yeah, and that's what we want to do today. I mean, cut through all the hype and really give everyone a good grasp of how Kubernetes works, like at its core,
Yeah.
what it's all about.
Right, the architecture of it all.
Exactly. Our goal in this deep dive is to demystify Kubernetes, made clear. So think of it this way. You've got all these different pieces of an application, all these little self-contained packages called containers. And Kubernetes is the system that brings them all together, makes them work together.
Like an orchestra.
Yeah, exactly, like a conductor leading an orchestra.
I like that.
It's designed to make managing these complex applications, these cloud-native applications, much more understandable, much more manageable.
Much more efficient.
Yeah, exactly. So we're going to break down the essential building blocks that make all this orchestration possible.
And by really understanding these fundamental components, and how they all fit together, it'll give you a much clearer sense, not just of what Kubernetes is, but why it's so powerful, why everyone's talking about it.
All right, so let's start with that first key element, the node. What exactly is a node in the world of Kubernetes?
Well, in the simplest terms, a node is just an individual computer that runs your applications. This could be, a physical server in a data center or a virtual machine running in the cloud.
Okay.
Think of it like one musician in our orchestra analogy. Each one is an independent entity, but they all contribute to the overall performance.
Okay, so we've got these individual computers, the nodes. Now, what happens when you have a collection of them?
That leads us to the idea of a cluster.
A cluster,
Yes.
okay.
A cluster is simply a group of these nodes all working together as a unified system. If a node is a musician, then the cluster is the whole orchestra performing in sync.
Gotcha. So what makes a cluster so powerful?
The real strength of a cluster is its ability to provide resilience. See, if one of those node musicians has a problem, the applications running on it, they can be moved to other nodes within that cluster,
Uh-huh.
which means that your service, your application, it stays available even when things go wrong.
That's really cool. So it's like having backup musicians ready to step in,
Yeah.
so that the show can go on without a hitch.
Exactly.
Now, we've mentioned the conductor a couple of times. That's the master node in Kubernetes, right?
That's right. The master node is like the brain of the whole system. It's the control plane. It doesn't actually run your applications itself,
Okay.
but it makes all the high-level decisions about where those applications should run. It's managing the overall health and state of the cluster,
Yeah.
keeping everything organized, running smoothly. It's vital. It also stores the cluster configuration, like the settings and stuff, in a distributed key value store that makes sure that all the nodes, all the parts of the orchestra are on the same page, about how things should be.
Okay. And so if the master node is the conductor, what are the worker nodes?
The worker nodes are the ones actually playing the instruments, running the applications, as our source puts it.
Okay, so they're the ones actually doing the work. And what exactly are they running? That's where the concept of a pod comes in, right?
Exactly. A
Yeah.
pod, you can think of it like a suitcase.
Okay, I like that.
It holds one or more containers. These containers, they're all very tightly linked. They need to work together to function as a unit.
Okay, so like you can have more than one container in a pod.
Absolutely. The containers within a pod, they share the same local network, they share the same storage resources, which really simplifies communication between them. This close proximity and shared resources make it much easier to manage the components of a single application that need to work very closely together.
Okay, so it's not necessarily one container per pod. It's about how tightly they need to be integrated.
Exactly. It's like packing, related items together in your suitcase so they're easy to find and use.
That makes sense. Now, the last of these key building blocks we need to understand is the controller. Our source refers to it as the stage manager. What's its role?
Ah, the controller. Its main job is to make sure that the actual state of your application in the cluster matches the desired state that you've defined.
Uh-huh.
So a key aspect of this is making sure that the right number of pods are always running. If a pod fails, maybe there's an error in the application, maybe the node it's running on has an issue, whatever the reason, the controller detects that discrepancy and automatically takes action to fix it. Usually it'll just create a new pod to replace the one that failed. It's constantly monitoring, constantly adjusting to keep your application running just the way you want it.
Okay, so it's always making sure the show goes on. So we got the nodes, the cluster, the master node, worker nodes, pods, controllers. I think I'm starting to get a much clearer picture of how these all fit together. But how does Kubernetes actually make all of this happen?
Yeah.
What's the process like?
Okay, so the process starts with you, the user, defining how you want your application to run. And you do this by creating a configuration file, what we call a manifest.
Okay.
Think of the manifest like the director script for the orchestra, right? It details how many musicians, which instruments they play, how long they play, all the details. This file specifies things like how many pods you want, which container images they should use, all sorts of configuration details.
And just to be clear for our listeners, a container image, that's basically a packaged up version of an application, right?
Yeah.
With everything it needs to run.
Exactly. It's like having all the sheet music and all the instrument specifications ready to go.
Got it.
So you, the director, submit this manifest, these instructions, to the conductor, which is the master node.
And what happens next?
Well, the master node receives your manifest, and then it has to figure out the best way to make it all happen within the cluster. It looks at the resources available on each worker node, and based on the requirements you've laid out in the manifest, it decides which nodes are best suited to run your pods.
So it's like the conductor reading the score and assigning different sections to different parts of the orchestra based on their capabilities and, who's available.
Precisely.
Okay. And then the worker nodes, they get to work based on those assignments.
Yeah. They receive their instructions from the master node, and then they go and fetch the necessary container images from a registry.
What's a registry?
Oh, it's basically a library for container images, like a central repository where all those prepackaged applications are stored.
Okay.
So the worker nodes grab the images they need and then start running those containers inside the pods they've been assigned. And remember, as we talked about earlier, a single pod can have multiple containers working together.
Right, like those tightly packed suitcases. So it's like the musicians, they get their music, their instruments are all ready, and they start playing their parts in their designated sections of the orchestra.
Exactly.
Now, what if a musician misses a note? Or in our case, a pod encounters an error and stops working. That's when the controllers step in, right? Those stage managers.
You got it. The controllers, they're constantly monitoring the whole cluster. They're checking the health and status of all the running pods. If a controller sees that the actual number of running pods doesn't match what you specified in your manifest, like if a pod has crashed, it'll automatically take action to fix it.
No.
Usually by creating a new pod to replace the one that's gone wrong. So your application, the performance, keeps going without a hitch.
So it's all about keeping the show running smoothly, even when there are unexpected hiccups.
That's Kubernetes in a nutshell.
This whole system sounds incredibly resilient and efficient. Why has Kubernetes become such a crucial technology? Why is everyone adopting it?
There are several key benefits that have driven its popularity. One of the biggest is scalability. As the demand for your application grows, Kubernetes makes it super easy to scale things up. You simply increase the number of pods, and Kubernetes handles all the details of provisioning them on the available nodes. And when demand goes down, you can scale back down just as easily. It's like being able to seamlessly add or remove musicians from the orchestra depending on the needs of the performance.
That's amazing. So you can just adapt to changing demands really easily.
Exactly. And Kubernetes does this through what we call horizontal scaling. You add more instances of your application rather than trying to make a single instance more powerful, which is vertical scaling.
Okay, that makes sense. What's another advantage of Kubernetes? Our source mentions high availability.
High availability is super important for a lot of applications these days. It basically means that your application is always accessible even if there are problems. And because Kubernetes spreads your application across multiple nodes and can automatically replace failed pods, you get that high availability.
Okay, so even if one server goes down, the application keeps running.
Exactly. It's like having understudies ready to take over if a performer is sick. The audience never even notices the difference.
Wow. And our source also talks about self-healing. We've already talked about this with controllers, but it seems like a really valuable feature.
Oh, it definitely is. Self-healing basically means that Kubernetes can automatically fix problems without any human intervention. This takes a lot of the burden off of operations teams who would otherwise have to manually intervene whenever there's a problem.
There must save a lot of time and effort.
Absolutely. It's like having a backstage crew that can handle those minor issues without interrupting the performance.
So I've got scalability, high availability, self-healing,
Yeah.
all really valuable. What's the last major benefit? Portability, right?
Yes. Portability is a huge advantage of Kubernetes. It basically means that you can run your applications anywhere. You're not tied to a specific cloud provider or a specific type of hardware. You can run Kubernetes in the cloud, on-premise, or even in a hybrid environment.
So it's very flexible.
Extremely flexible, like an orchestra that can perform in any concert hall without having to change its instruments or its music.
So to recap, Kubernetes is this sophisticated system that manages your containerized applications,
Yeah.
with all the precision and control of an orchestra conductor. It gives you the ability to easily scale up or down. It ensures that your applications stay running no matter what, and it lets you deploy those applications wherever you want. It's a really impressive system.
It is. It brings order and reliability to what can often be a very chaotic world of, modern software development.
Yeah. This has been a great deep dive. I think it's really clarified a lot of the core concepts of Kubernetes. Now, as a final thought for our listeners, think about this idea of orchestrated self-healing systems and how it could be applied in other areas, not just software. What other complex systems could benefit from this kind of approach? Where we have independent units working together with built-in redundancy and the ability to recover automatically from problems. It's a fascinating concept to consider.
Absolutely. It makes you think about the possibilities.
It really does.